In this video, we're going to see a couple problems that we could solve using systems of linear equations. Example 1 says the sum of two numbers is -14. One number is 4 less than the other. Find the numbers. Let's take a look at this one sentence at a time. The first sentence says the sum of two numbers is -14. So let's translate what we know. A sum means that we are going to be adding. We have two numbers, and we don't know what they are, but we could call them variables x and y. We know the word is, not always, but a lot of times, is an equal sign. And then -14 we could translate into just the number -14. That first sentence is giving us our first equation. The sum of x and y, we would write that as x plus y is -14. There's our first equation. Let's look at the next sentence to try and find the next equation. One number is 4 less than the other. We know is a lot of times our equal sign. Less than, that means a minus. So let's see if we can do this one. One number, doesn't matter which one, we'll just call it x, is 4 less than the other number. Now remember, when subtracting, order matters. 4 less than y. That's going to be y minus 4. There is our system of equations to solve. Once we're here, we need to decide how we want to solve this. We could use graphing. We could grab some graph paper and put them in y = mx plus b, do it that way. We could use substitution, or we could use that addition/elimination method. I think this one's set up very nicely to use substitution because we already have a variable by itself. So I think I'm going to use substitution. I'm going to take the value of x, which is y minus 4, and substitute it into this equation where there is an x. So let's rewrite that top equation. But instead of x, I'm going to put in the value of x, which is y minus 4. The rest of that equation does not change. And let's see if we could get that solved. So we've got a couple y's that are on the same side. They're like terms, so we can put them together. 1y plus 1y is 2y. Still have the minus 4 and the -14 on the other side. To get y by itself, up next, we're going to move that 4. So we're going to have 2y equals -10, and we could solve for y. We've got y equals -5. So one of the numbers is -5. We could then take that value of y and plug it back in to this equation that we started with. We know that x is equal to y minus 4. And now I know what y is. Y is -5. And -5 minus 4 is -9. So the two numbers that we were looking for are -9 and -5. You can do a quick check by making sure this makes sense. The first number says the sum of the two numbers is -14. If you add these together, do you get -14? Sure you do. One number is 4 less than the other. -9 is 4 less than -5, also checks. Now remember, we use substitution here, but you can do any method that you'd like. You could have graphed these. You could have used the addition/elimination method. You would have had to do a little bit of moving around, but it would have worked out just fine. It's going to be up to you to use which method makes the most sense for that problem and for you. It may vary from person to person on what seems like the logical choice. Let's try number 2. There are a total of 250 people at a baseball game. Admissions for adults were $6, and for kids it was $4. If they collected $1,344 in admission fees, how many adults were at the baseball game? This one's a little bit different because it has a bit more context than the last one. The last one was what we call a translation problem. You're just taking it from words to math. This one has a little bit more context. We know that our variables have some serious meaning here. And so before I even start, I'm going to identify what those variables are. We know that we are talking about two specific things here. We're talking about adults and we're talking about children. So I'm going to start by saying X equals either adults or children. It doesn't matter. I'm going to say adults. And if I'm going to make X adults, that means my Y has to be children. You could have flipped them. It'll just make a difference at the end on which one's which, and you got to keep them straight. So that's why I like to identify them before we even get started. When you look back at this problem, we know that the adults are $6, the children are $4, and we have two other very important numbers. We have 250, which tells us the total number of people, and we have 1,344, which tells us the total value in money that they brought in. These two numbers, the 250 and the 1,344, are both totals, and we're going to use those to write two equations. One equation is going to be total number of people. The other one is going to be total number of dollars or money. So let's start with people. There are 250 people at this baseball game. Some of them are adults and some of them are kids. So if you add the adults and the kids together, we know we have to get 250 total people. So that's your total people equation. Next, we got to do total money. This one's a little bit harder. We've got to get to $1,344. Well, how much money are they making on each adult? Each adult cost $6 to get in. So if you had 10 adults, that would be 6 times 10 or $60. If we had 100 adults, that would be 6 times 100 or $600. We don't know how many adults we have. We have X number of adults. So the money brought in by adult tickets would be 6 times the number of adults. We just don't know how many it is. We're going to add that to the money that was brought in by the kids. They're $4 a piece. So we need to take 4 times the number of kids. Well, the number of kids is Y. And all together, we made $1,344. There is your system of equations. The top one is dealing with people, and this one is dealing with money. Now we need to decide how we're going to solve these. We could very easily get this X or Y by itself and use substitution. If that's your favorite, do that. There's nothing wrong with that. I kind of like the elimination or addition method, so I'm going to use that one here. I need to get either these X's to cancel or these Y's to cancel when we add the two equations together. I think I'm going to do the Y's, and in order to get them to cancel, let's see, the bottom one's 4Y, so I need the top one to be -4. So that means we're going to take this equation and multiply it with -4. Legal as long as we do it to everybody in the equation. So let's rewrite that top one after we multiply everybody by -4. It's going to be -4x minus 4y. Remember, you have to multiply everybody, including the 250. So that's going to be -1,000. The bottom equation did not change. Now we should be able to add these two equations together. -4x plus 6x is 2x. Negative 4y plus 4y cancels out. Negative 1,000 plus 1,344 is 344. And then we're going to divide by 2 to get x. We know that x equals 172. Once we know one variable, we can find the other. I'm going to go back to this one. You could use either one, but I'm going to use this one just because the numbers are a little nicer. We know that x plus y equals 250. And I now know that x is 172. So wherever you see x, we're going to put in 172, and then we can solve for y. We're going to get y equals 78. So now we know the value of x and y. Let's go back and answer the question. The question was, how many adults were in attendance? Remember, back at the beginning of this problem, I said my adults were x. So the answer to this question is 172 adults. If it had asked how many kids were at the baseball game, then your answer would have been 78 because y was the kids. Always double check that you're answering the question.